Hello guys, and welcome back to another episode of chemistry. And of course, today we're going to continue our study on amides. Okay, specifically today we're going to be talking about the preparation of amides. Okay, so how do we prepare what amides? Okay, so I've already hinted on some methods we can use to obtain amides, so I'm going to see them in details now. Okay, so do not forget that this tutorial is brought to you by the O3SCHOOLS JAMB CBT practice app. It is all you need to succeed in your exam. We'll talk about the app in a moment, but let us see a question from the application. This is a 2013 JAMB past question. Okay, relating to this, number 40 says the reaction between ammonia and ethyl ethanoate produces A, it said ethanol and propanamide. B says ethanol and ethanamide. C says propanol and ethanamide. D says propanol and propanamide. Okay, so we're going to come back to this question at the end of the class and not before, because in O3SCHOOLS we believe in giving you value first. Make we first teach you, and after you have learned, answering question will be the list of your problems. Okay, so please ensure you download the application. The app has all the past questions for all subjects in one application, so you don't need to go and buy past questions. The app has lecture notes structured according to the JAMB syllabus, so you don't need to bother about JAMB syllabus, you don't need to bother about textbooks. The app has question search feature where you can search for questions, just like the way we brought out this question now. You can search for amides and questions under amides will come out for it. It works for every subject. Then likewise, it has mock challenge every Saturday. Every Saturday by 10 a.m. you sit for a mock exam. You compete with all the students that are writing JAMB for this year. Compete with them to win prizes. Compete with them to familiarize yourself with JAMB past questions. To familiarize yourself with JAMB likely exam question, as well as also you see your result released every Saturday, thereby building your confidence toward the main exam. Please do not sleep on the application. It's available for both your Android phones and available for your computers or your laptops at home. Okay, so to download for your laptop, simply go to o3schools.com/jam app. If you need help with downloading for your laptop or PC, or you're facing any challenge, send a message to this number on WhatsApp. 09121515246. Okay, and one of our customer care will be there to attend to you. All right, so now let us go to preparation of amides. Do not forget that you need to activate the app. Activation fee is not up to the price of rice and chicken in a very good restaurant. So please ensure you activate, pass your JAMB at once. That should be your major focus. How do you prepare amides? I've hinted already that we can obtain amides, okay, from carboxylic acid derivatives by their reaction with ammonia. Carboxylic acid derivatives like esters, like acyl chlorides or acid chlorides, and from acid anhydride. So I'm going to look at them, okay, and of course we'll be done with this class. So number one, I'm going to see the reaction between ammonia with acid chlorides, or with esters and acid anhydride. So let us see the first one, a reaction between ammonia, this is our ammonia, okay, and acid chlorides. Okay, so when an acid chloride reacts, okay, with ammonia, it gives us an amide, which we're talking about now. It gives us an amide as well as as a salt. Okay, it gives us also a salt as a product. Right. So now basically, let me just say reaction between ammonia. Oh, sorry, between ammonia. Reaction between carboxylic acid derivatives, okay, and ammonia. I want to shorten it. All right, so now firstly we're going to look at with acid chlorides. With acid chlorides, okay. So when an acid chloride reacts with ammonia, okay, what do we have? We're going to have an amide plus a salt. So let us see an acid chloride. For example, we have iron COCl. This is our acid chloride, okay. This is our acid chloride. Okay, if it reacts with ammonia, NH3, this is our ammonia. Okay, what are we going to have? Okay, we're going to have what? Our amide, that is what? ROCONH2, then plus what? NH4Cl. Okay, this is our ammonium chloride, and this is what? Our amide. So this is our amide. Okay, this one is our what? Our ammonium chloride. All right, so that is what happens when what an acid chloride reacts with ammonia. Okay, we'll get what? An amide and what? And an ammonium what? Chloride as what? As product. So please take note of that and put that at the back of your mind. So also, it can react with an ester. Okay, it can react with an ester, which is another carboxylic or alkanoic acid what? Derivative. Okay, so it can react with an ester, and when it does so, it also give us what? Gives us an amide and an alcohol. Please take note of that. Okay, for esters, it gives us an amide and an alcohol. Let us see an example with ester. Okay, before we talk about the ester, let us take an example on this so that what will not come back to acid chlorides any longer. That's clear, right? So let's say we have what? An acid chloride like butanoic chloride. Okay, we have CH3, CH2, CH2. Okay, then you have your C, the body to O. All right, they are now going to have what? Our Cl. Okay, C double to O. I'll say our bonds are complete. 1, 2, 3, 4. Complete your bonds. All right, make sure your bonds are complete. So this is what? 1. This is 2. This is what? 4. 1, 2, 1, 2, 3, 4. So it's very, very complete. This is our butanoic chloride. It's an acid chloride. So this butanoic chloride is reacting with what? With ammonia now. With ammonia. Now, the source of nitrogen, okay, please take note of this, that for this reaction, for acid chloride, the source of nitrogen must be 2 molar equivalent, okay? There must be 2 molar equivalent of what? Of the source of nitrogen. So this reaction will not be complete if we do not put 2 here, all right? It will not even be correct. So we must use what? 2 molar what? Equivalent of what? Of the source of nitrogen to produce this amide and what? And the ammonium what? And the what? And the salt. Okay, one of the nitrogen source, one of the molar equivalent of nitrogen source is for the amide. The other one is for producing what? The salt. One is for producing the amide. The other one is what? For producing what? The salt. That's why we use 2 molar what? 2 molar what? Equivalent of what? Of the nitrogen source. Okay, so now let us use what? Another nitrogen source. Let us not use ammonia. So let us use what? An amine. Okay, let us use an amine, like let's say methylamine, CH3 NH2. This is also another what? Nitrogen source. Okay, so it doesn't have to just be what? To be ammonia. You can use what? Any nitrogen source. Okay, so like ammonia can work also. Like methylamine here can work, just like where ammonia works here. So now we can use that. This is what? This is our methanamine or what? Methylamine. All right, so this works perfectly. Then now what are we going to have as product? As product, are also going to have what? We're going to have our what now? Our, what's it called? Our amide. Our amide will carry what? This is the first R it will carry. All right, the first R here, this 1, 2, 3 carbons, it will take the 3 carbons. So let's go. We're going to have CH3, CH2, CH2 because of space. Let me come up, please, because of space. Let me come up because of space. Acid chlorides, I was talking about acid chlorides. Because of space, let's come up so that we'll see it very clearly. All right, so we're going to have what now? CH3, CH2, CH2, then our C double to O, Cl. Okay, this is what? Our butanoic chloride. I'm bringing everything back up. Butanoic chloride. Okay, then reacting with ammonia with our nitrogen source, that like methylamine, CH3NH2. This is our methylamine. Okay, and then we know that our product will be what? Will be an amide and a salt. Okay, so methylamine. Then what will be our product now? We're going to have what now? Our amide carrying this CH3, CH2. CH2, okay, C, all right, then what? Double bonded to what? To O. Let me just put this double bonded to O, okay. I would like to write it out in a stretch, please, so that it will be clearer, okay. So I'm going to have something like this: CH3, CH2, CH2, C double bonded to O, okay. Then I'm going to have what now? Our NH CH3. Okay, so we're going to have what? A secondary amide here. What we have here is what is a secondary amide. Why? Why are we having a secondary amide? Remember here, we must use 2 molar equivalent of the nitrogen source. So plus 2 here. I'm adjusting this so I can put the plus 2 here. One of the what? CH3 will go for what? For the what? For the amide. The other what? CH3 will go for the what? For the salt that wants to be formed. That's what we did. So go back to that general reaction I dropped before and understand it perfectly, and then come back here, you understand it. Okay, so this first arrow part. The first arrow part in this what in this acid chloride is what is here. CH3, CH2, CH2. Okay, then C double bonded to O. Then of course I'm going to have our NH. Going to have our NH, all right, then now have your CH3 to show that what it's a secondary amide. This is secondary amide. So what will this one be called? This will be called N-methyl. This N-methyl what? Butanamide. Butanamide. Okay, because there are 4 carbon atoms. Yes, 1, 2, 3, 4. So that will be N-methyl butanamide. Then of course, then plus, it's not finished. I'm going to have our CH3, the other CH3, okay, that is from here now, for making the salt. Okay, for making the salt, I'm going to have CH3, then I'm going to have what now? NH3Cl minus, okay? NH3 plus, then Cl minus. So this is what, this is our carbon, what's called, this is our what? Methyl ammonium salt. This is our methyl, this one we call methyl ammonium chloride. Okay, so it's simple as ABC. Let us go over the reaction again. We have what? An acid chloride like butanoic chloride, CH3, CH2, CH2, bonded to O, then Cl, then plus what? Our what? Nitrogen source, which is methylamine. We use methylamine here or methylamine. Okay, we're using what? Methylamine here because it's also what? A source of what? Of nitrogen, and we're using 2 molar equivalent of what? This nitrogen source. Okay, so we now form our what? Our N-methyl or butanamide, which is an amide. CH3, CH2, CH2, C double bond, NH, CH3. Then we're now going to have what? The last what? CH3, CH3, NH3 plus, then Cl minus. Okay, so now our methyl ammonium chloride. So somebody may ask, why is this CH3 here? I told you before that what? The reason why we use 2 molar equivalent here is because one of the nitrogen source will go to the what? To the amide, while the other one will go to the what? For the formation of the salt. Okay, so we have already carried this first part, this first arrow part here. All right, this one that is supposed to make the amide, what would it now be? It has to be attached to the nitrogen, and because nitrogen is supposed to be like this, NH2, 2NH. So if we have used one of this CH3 here, okay, there's nothing here again, so here will be left out. So that's why we formed what? We're able to form a secondary amide there. All right, so I did not just form it. Okay, I not just say this is how it should be. I'm telling you why it happened like that there in that formation. So we're able to what? To form a secondary amide plus what? Plus a salt. Okay, which is called methyl ammonium chloride. So very simple. These are what we carboxylic acid derivatives like acid chloride react with what? With ammonia to give us amide and what? And a salt. Now let us see for esters. So I've told you also that already that for esters, when an ester reacts with ammonia, what it gives to us is an amide and an alcohol. It gives us an amide and an alcohol. So let us see with esters. So when an ester like this, arrow COO arrow prime reacts with what? With ammonia, NH3. So what we have is what? Is arrow CO NH2, which is what now? Our amide. Then plus what now? Plus alcohol, arrow O what? H. Please take note of that. It's very, do not forget this. Okay, when an ester, this is our ester. Okay, this is our what? Our ammonia. Okay, then this is our amide. This is our what? Our alcohol. So please take note of that. When an ester reacts with ammonia, what we have is what? Is an amide and what? And an alcohol. Then also let us go on. Let's say let us check for acid anhydrides. Okay, when an acid anhydride reacts, when an acid anhydride, acid that is with acid anhydride. Okay, when an acid anhydride reacts with ammonia, an acid anhydride is like this: arrow C double bonded to O, then O. Okay, then C double bonded to O, then arrow prime. This is our acid anhydride. acid anhydride. Okay, you can see the way I'm not breaking in this part because it's a little bit above your pay grade, but of course it's very, very understandable. That's why I'm adding it. So this will be useful even in your first year in your university. So do not sleep on it. So this is acid anhydride. It can react with ammonia. When it reacts with ammonia, what it gives to us is what? It's an amide, NH2. This is our what? Our amide. Okay, while this one is our ammonia. Okay, then it also gives us what? C double bonded to O NH4 plus. So this is also what? A salt. This is a salt. So this is a carboxylic acid salt. A carboxylic acid salt that it gives to us. So when an acid anhydride, which is also a derivative of what? Carboxylic acid, reacts with ammonia, what it gives to us is an amide and a carboxylic acid or salt. So please take note of what of all those who were very important ones we have looked at acid chloride, especially esters, because we saw an ester question in your past question. So please make sure you took note of what of that ester what part. Now let us see. Let's go to the O3SCHOOLS JAMB app and answer the questions that were before us, and we are done with this class. 2013, number 40. It says the reaction between ammonia and ethyl ethanoate. Okay? Reaction between ammonia and ethyl ethanoate. Reaction between ammonia. So we have what? Ethyl ethanoate. What is ethyl ethanoate? Ethyl ethanoate. Okay, so that means we have what in this is arrow COOR prime. Okay, that means this arrow is what is ethyl. Okay, so I'm going to have what C2H5 COO. Then this arrow is what is ethanoate. That's having what C. So C is directly bonded. So this is what actually what CH3. This is CH3 COO C2H5. This is our what? Our ethyl ethanoate. So I'm not going to go back to how I got this because we have done esters before. All right. So this oxygen is already bonded to the what? Is one that is part of the continuous chain. This oxygen, this first oxygen is what? Part of this carbonyl carbon. So it is bonded to what? To this carbon, double bonded to this carbon. This oxygen is part of the continuous chain. Okay. So we have to understand that one first. Now, since it is ethyl, then that means this place what is our ethyl. This arrow prime is our ethyl. So I have ethyl here. Then what? Ethanoate is cutting from further what? There's what? There's a methyl group here and there's one carbon here. So makes it what? Ethyl what? Ethanoate. Now, let us proceed. So what are we going to do now? This is our ester that is reacting with what? With ammonia, NH3. So what are we going to have? That's what the question is asking us. What will be the product of this reaction? All right. We already know that we're going to have what now? An amide and a what? An amide and a what? And an alcohol. We just saw that in very few minutes ago. So we're going to have an what? An amide plus an alcohol as product. So what is the amide that we're going to form there? So we're going to have our arrow. This is our arrow. Okay. We're going to have what? Our CH3, C double bonded to what? To O. We're going to have this. Then dash what now? NH what? 2. NH2. Okay. Remember that this does not require us to have 2 molecules of ammonia. It does not require us to have 2 molecules of ammonia. So it's only when we're dealing with acid chlorides we give that condition. For ester formation, no, it will not give that condition. So our amide that will be formed here will be what? CH3, C double bonded to O, NH2. This is our amide that will be formed. Then plus what now? Plus what now? Plus an alcohol. What is the alcohol that will be formed here now? I'm going to have what? This acid now. So I'm going to form what? Our alcohol. What is left from here is what? C2H5, and then we have one O here. Then we have one H left out of here. H. So that's what? Ethanol. This is our ethanol. And then this is called our what now? What is this called? It's ethanamide. I hope you understood. It's because we answered the question. That's why I'm fast. Okay, let me take it slowly. We already know how we form this our ester, right? So I'm not going to go back to how we form this ester. Okay, now it's reacting with ammonia. Since it's reacting with ammonia, this first arrow part will come here. Then our carbonyl carbon, C double to O will follow. Then we're not going to have our NH2. But we're not going to have anything like what? NH3 here because we are using just one molar equivalent of all this ammonia. So this one is formed. This is what we formed here. CH3, C double bonded to O, NH2 as our amide. This one is ethanamide. Then what will be left? What will be left is what? C2H5. We have not used anything like C2H5 to form any amide here. So C2H5 is left. What will be left again is O. O is left. From this COO, we only use C double bonded to O. One O is left. Then what will still be left again is what? Is H from here because we use NH2 to form the amide. We use 2 atoms of hydrogen to form the amide from this ammonia. Then 1 hydrogen will still be left. So that's why we now form what? Our ethanol. So let us look at our option. What should be looking in our option should be what? Ethanol and ethanamide. A says ethanol and propanamide, very wrong. B say ethanol and ethanamide, very correct. C say propanol and ethanamide. D say propanol and propanamide. Correct answer there is option B, ethanol and ethanamide. So let us see another question. All right, they said that a primary amide is generally okay. We have seen that question. What's the general formula for amide? I've seen that. So please just enjoy yourself. Look for questions under this and enjoy yourself. Okay, just keep answering questions. All right, keep sharing questions. That's what the app is for. All right, there are many questions on the application. Go and search for questions, answer, and study vigorously and succeed in your exam. My name is Master T. I'm the Grand Commander. I'm the overall Grand Commander of this O3 Schools Army. Join our Telegram group, okay? Just go to download Telegram on your Android phone. After you downloaded Telegram, then just quickly, immediately search for what now? O3 Schools Army. O3 Schools Army. Okay, and join our Telegram group, okay, for update. All right, so I'll see you in the next episode. We'll conclude our teachings on on the amides by talking about the reactions that amides undergo. See you there.